Namaste students, welcome back to my channel BMSR Mathematics tutorial. Today we are going to learn about the circles. What we learn in the circles today is in the chapters. You see here we learn about the introduction of circles, tangent and tangent to a circle. Tangent at any point of a circle is perpendicular to the radius through the point of contact. Means the first lesson of the circle today we learn. Now, what is called circle? Yes, circle is a collection of set of all points in a plane which are equidistant at a constant distance from a fixed point. This is the definition of the circle. But what is the meaning of the definition? That one I'm trying to explain to you. Now you see here, first time consider a confined plane. This is a confined plane. In this confined plane there have so many points, and in that so many points I consider here a single point. Yes, single point, and from this single point there are some set of points, means collection of points, and these collection points are equidistant from this fixed point, and we give the name of the fixed point as O, and they from this point we consider name a point here A, and here it is B. Suppose A and B, these are the 2 points of the collection of points. From O to A and from O to B they are equidistant. Like that all these points are equidistant from the point O. So these set of points, if they formed a closed curve, like that they will form the closed curve. So this closed curve is called that, it is called a circle, and the distance from the point O to B, distance from the O to A, means to the circle, it is called a radius, and these are equidistant, means equal distance. This is the definition of the circle. Yes students, we come to the next point. Now students, you see here we are going to explain about the tangent. Before going to tangent, we try to learn this figure. Yes, what is here? This is there. I have given here 3 circles, which is in your textbook, 3 circles, and there are 3 lines. You see here in the first figure, the line and the circle, they are not intersect at a point. In the second figure, the line intersect at 2 points. Yes, this is the one point. The one point name is as A, the other point as B. But here in this figure they intersect at only one point, and we give the name of the point is as P, and give the name of the line as this is give the point as A, we give the name as A, and the name of the line as PQ. Yes, and this PQ is called the tangent. Why it is called tangent? Because this line PQ intersect at only one point of the circle. So the point A is the common point of the line and the circle, means the point A is belong to the line PQ and it belongs to the circle also. So this is the common point of the circle, and hence this PQ is called the tangent. Yes, and the other figure, in the second figure, the line, this line is called a secant. What is this called? Secant. Secant, it is called secant. So we, in the textbook we have got in the figure, in the third figure, means in the third figure, here in the third figure, yes, only one point A, which is common to the line PQ. Yes, PQ is the PQ, for PQ A is the common point. So this PQ is called the tangent of the circle. Here we learn about the definition of tangent of the. Now students, we learn in the next point how many tangent can be drawn at only one point. Here is the figure is given. Here is the figure in your textbook. From the textbook I have taken in this figure, how many tangent can be drawn at only one point. Now if I take here, there is a one circle. I have taken one circle, and I consider a point here, and through this point, how many lines can be drawn? I consider a fixed point here. I consider a fixed point here. here is the fixed point, here is the fixed point P. Yes, this is the fixed point, and through this point, fixed point P, which is belongs to the line and the circle, and through this point P, how many lines can be drawn? Now this line, the first line, it passes through 2 points, yes, of the circle, but if we draw in this way, only one line possible to draw through this point P, only one line possible to draw through this point P. So means at only one point, only one tangent possible to draw. Yes, not more other than only single tangent can be drawn through a one point. Yes. Now in this circle, now here so many points. Here so many points. Here is the one point. If I say A, at this point A, only one tangent. At this point B, only one tangent. At this point C, only one tangent. Means but a infinite tangent can be drawn to a circle, but at only one point, only one tangent. Yes, infinite number of tangent can be drawn from defined points. Yes, from defined points. From different external points we can draw defined number of tangents. Infinite number of tangents can be drawn. Here from this external point one tangent, and from this other external point one more tangent. Infinite number of tangents, but at only one point only one tangent can be drawn. Yes. Now here again we are going to learn one. Now the last point, that point we have going to learn. Here it is said that tangent to a circle is a special case of the secant when the two end points of its corresponding chord coincide. Means here it is a circle. I consider a circle here. We consider a circle, and that tangent is a special case of the secant. Now this is first we draw a secant. This is a one secant, and now we draw some parallel secant. Yes, here we, sorry, that one is not, we draw a parallel secant, one more parallel secant. This is the another parallel secant, and we draw one more parallel secant here. Yes, this is also a secant, but it is then if we draw in this way, that parallel secant, it will, yes, it may not be parallel. Here it is on intersect only one point. You see, yes, students, that will be one more secant. Now the last we draw, that, yes, that will be the parallel one, and it intersect on only one point. It means that, it means here in the circle, these are all are secant. These are all are secant. It intersect at 2 points, A 1 points and B 1 points. Yes, here also intersect at A 2 points and B 2 points, and here it is intersect. But when it is gradually away from the center of the circle, these 2 points are coincide here and they intersect at only one point of the circle. So this secant, it turns to tangent. Now it is called tangent. It is called tangent because it intersect at only one point. So that this line is called tangent. Yes. So it is called that this is a tangent. It intersect at only one point. This is a secant, and so it is called that tangent is the special case of the secant of the circle. Yes, students. So from this statement we learn special case of. Lastly, we are going to learn that tangent and radius is perpendicular to each other. That one we are going to learn. Yes. Now you see here, if we consider here, this is a path, and this is a path, and this is the circle, and circle means the wheel is a circle. Yes, the wheel is in the shape of a circle here, and these are the radius. When the wheel is moved from, when the wheel is moving, yes, you see, when this wheel is moving, that it is perpendicular to the path. It is perpendicular, and that this is the radius when it is moving. So this line it will be, it goes to this position, and but this radius, another radius, it comes to this position. Now is not it, it comes to this position. So the radius will be the perpendicular to the tangent at the point of contact. This common point we now it is mentioned, it is as point of contact. This common point of the circle and the tangent is called the point of contact. Or we can say that the tangent touches the circle. Tangent touch the circle. What is that one? Tangent touch the circle. Yes. And now lastly we are going to define the tangent at any point of a circle is perpendicular to the radius. Perpendicular to the radius. It is by theorem, by geometrically how will you prove that? Now you see here this is a circle and this is a tangent. Yes, this is a tangent, and tangent point of contact is P. Means P is also one point of the tangent. P is one point of the tangent. Now this name of the tangent is considered as y x. Y x is a tangent, and tangent is also a line here. Q is the another point. Q is the another point of this line xy. From the point O means center of the circle, the distance O to P and distance O to Q, distance O to P and distance O to Q, OQ, which is greater than OP. Yes, greater than OP. Similarly, here will be that so many points R, then S. These points are always greater than the radius. Always greater than the radius. And OP is the radius, which is less distance. It is the less distance to the line xy. Less distance always perpendicular. Less distance is always perpendicular from the external point. External point is O here. So OP is perpendicular to xy. So by this theorem, statement of this theorem explanation, my video is over. Please like this channel.